Hey guys, so this is section 8.4. We're going to look at pressure volume and pressure volume temperature phase diagrams. So let's look at a pressure volume phase diagram, the one on the left here first, as opposed to pressure temperature, which we saw in the last section. We get some different information from a pressure volume phase diagram. For instance, the triple point, which we saw over here, it becomes a triple line. And the reason for that is that at this point, at this equilibrium, where the solid, the liquid, and the gas are all in equilibrium with each other, at that pressure and temperature, the volume changes because what happens is over here, you have almost all solid. Here, almost all gas. In the middle, there's some liquid as well. Also, when we go from solid to a liquid, let's say, we pass through this region here in the pressure volume phase diagram where there's some solid and some liquid. At this end right here, it's going to be pretty much all solid. At this end up here, it'll be pretty much liquid. But we do see there's a definite change in volume, and which makes sense as you go from a solid to a liquid. Now, when we go from a liquid to a gas, that region is much larger because the gas has a much higher volume than a liquid does. So as we go from here, from the liquid to the gas, as we pass through this region where there's both liquid and gas in equilibrium, this is a coexistence line, by the way, it's a pretty large change in volume because gas has a much higher volume than a liquid does. Likewise for sublimation. This process here, sublimation, that your book talks about, and it's kind of interesting. It's how they freeze dry food. So the idea is you start out with the food frozen, and so the water that's in there is going to be frozen too. And there's going to be an equilibrium, okay, with the gas phase of the water. It's going to be an equilibrium here. So what happens is as some of this solid water, ice, vaporizes, they have a pump that pulls it out of the chamber. And so this system is trying to come to equilibrium by increasing the amount of water vapor in the gas phase. And so it keeps coming from the solid, and they keep pulling it out until all of the ice from the food has sublimated and been pulled out, and now it's dry. So, okay, let's look at. This is a pressure volume temperature phase diagram for an ideal gas. So there's no solid or liquid. An ideal gas is always a gas. And what we see from here. Okay, this part right here is the three-dimensional pressure volume temperature graph. We can superimpose this on any two axes, and we get the pressure temperature phase diagram back here. So this red line becomes that red line. So each of these is a red line is a constant volume. Each blue line is a constant temperature here. And each of these gray lines are kind of hard to see, is a constant pressure right here. If we look over here, this is the pressure volume phase diagram that we get from this pressure volume temperature phase diagram. And again, it looks like this. So constant volume, constant pressure. Each of these blue lines is a different temperature. This is a pressure volume temperature phase diagram for a substance where the molar volume of the liquid is greater than the molar volume of the solid. And so we can see what happens is if we follow, there's kind of a lot going on here, but if we follow the path from A to B to C to D to E to F, this is above the triple point, above the triple line. So we start out with a solid at temperature, say T1, and we increase the temperature at constant pressure until we get to the melting point. That's at B. As the solid melts, the temperature stays constant, so this is here, but the volume's changing, right? The volume's increasing this way, and so as we go from a solid to liquid, the volume increases. Again, this is where the molar volume of the liquid is greater than the molar volume of the solid. Once it's all melted, then put thermal energy in, temperature continues to rise, the liquid, constant pressure, until we get to the boiling point right here. Then as we continue to put thermal energy in, the temperature stays constant, so this line is at the constant temperature, T3, I guess. But the volume, this axis here, is increasing because we're going from a liquid to a gas. And then once we get it all vaporized, as we put more thermal energy in, the temperature increases. If we do the same process for, let's see, if we follow GHIKLM, okay, this is at the same temperature. We're decreasing the volume. So we go here. So we're increasing the pressure. Solid gas equilibrium then becomes liquid here. So we increase the pressure, we get to solid liquid. Again, the volume's changing here, and as we increase the pressure, make it into a solid. This is all at the same temperature. So that is pressure volume and pressure volume temperature phase diagrams.